Okay, so in the previous video, we did the same integral, the integral of hyperbolic cosecant of x dx, but I did it using a trick and a method that I don't really like to do. So in this video, we'll do the same integral using a more straightforward method that I prefer. So to get started with this, I'm actually just going to rewrite this, and what I can do for cosecant, and what I can do for hyperbolic cosecant is just write it as 1 over sine of x, or 1 over sinh of x. And what I want to do is a u substitution, so I need something in the numerator. What I'll do is we'll just multiply numerator and denominator by sinh of x. So rewriting this over here, we'll have sinh x dx, and this is going to be all over sinh squared of x. But now for sinh squared of x, we have an identity that we can use that we found in like 2 or 3 videos back, I think. And it's just that we can write sinh squared of x as cos squared of x minus 1. The reason I do that is I want to set up the u substitution because the derivative of cos is going to be sinh. So let me just rewrite this whole thing really quick. And now what I'll do is set up my u substitution. We'll make the u substitution here just for cos. So for our substitution, I'm going to say we'll set u equal to cos of x. I'll take a derivative. Derivative of cos is going to be just sinh of x dx. So the whole numerator is our du. So when we rewrite this, we're going to have du over u squared minus 1. But now this is a really common integral. We'll just do this by formula. Let's just take a look at that. Now keep in mind there is another formula for this where we could express this in terms of inverse tangent. But to get the solution on the form I want, I think we'll use this formula over here. And just notice in this, our a value in this is just going to be this 1 or 1 squared. So this is going to be, our a is going to be 1 here. And so then using this with a equal to 1, we're going to just have 1/2 in front, natural log absolute value, and then we're going to have u minus 1 over u plus 1. But then let's just go ahead and back substitute with our u value. So when I rewrite this, we're going to have 1/2 natural log absolute value cos x minus 1 over cos x plus 1. And this is actually an okay solution, but I'd like to try to simplify it a little bit. Let's take the half. By log properties, I can bring the half into the exponent, and we can come over here and I can write this as square root of cos x minus 1 over cos x plus 1. But now what I think I'll do is let's just extend this square root, and I can multiply by the conjugate here. So I'll multiply by cos x minus 1, and we'll do the same thing here in the numerator. But then rewriting this again, in the numerator we're going to end up with, this is going to just become cos x minus 1 squared, and then multiplying this up, we're going to end up with cos squared x minus 1. But we found earlier cos squared x minus 1, that's the same thing as sinh x squared. So we'll just write it as sinh x squared here. But now because both terms are squared and we're inside the square root, I can write this as absolute value cos x minus 1 over sinh x. But now the absolute value is kind of redundant because we already had it on the natural log, but putting this back into natural log, what we have here is natural log cos x minus 1 over sinh x. And we can put a plus c on the end of this, but I actually want to try to manipulate this to get this in a couple different forms before we finish up. First, I'm actually just going to divide the sinh into it. So if I rewrite this and I divide cos by sinh, I can write this as hyperbolic cotangent x, and then minus 1 over sinh, I can write that as just minus cosecant, or minus hyperbolic cosecant of x, and then add a plus c. And I think this is a pretty common way to look at this answer. This is the way I usually do it, but there's other ways. But then one other thing I want to do in this is look at the half angle formula for tangent that we found a few videos back. And we found 2 formulas, but one of them was just cos x minus 1 over sinh x. And this had the restriction that x can't be equal to 0 because then sinh is equal to 0 and we're dividing by sinh. Because sinh is 0 is 0 and we're dividing by 0 there. But it's actually not a problem because we have sinh in the denominator in our original. So x can't be equal to 0 here either. So that was already a restriction. So because this here, this is actually the same as this here. So this right here is the same as tangent x over 2. I can write the solution this way as natural log absolute value tangent x over 2. Add a plus c, and that's it. Okay, there you have it, integral of hyperbolic cosecant. Thanks everyone for watching. Have a good day.